Hi, this is a foundation tier question from the GCSE Unit 1. It's all to do with the domestic electricity section, and this in particular is looking at the ring main inside the sort of house or a lab maybe. Okay, so it says, give two advantages to having a ring main. This is what we call a ring main. So the first is, you notice how each of these is looped off, so that will give us independent switching, which is a posh way of saying I can turn them on and off without turning everything on and off. It means that you can use the kettle without having to turn the toaster on at the same time. And then my second advantage I'm going to go for is, because there's two ways the current can go around the circuit, it's going to reduce that current and reduce the potential heating effect or resistance from that. So we're just going to put reduces current in the wires as there's two ways to go round. So state the function of the live wire. This is a very common question, this one. It comes up over and over again. It's just recall, so it carries the current at 230 volts to the appliances. Okay, describe the function of the earth wire. Again, another familiar question. This one provides a safe route to ground. Don't say earth, say ground, in case there is a fault, to prevent can't spell it, fusion. Okay, so that earth wire is there in case the live touches part of the metal casing perhaps, and then to prevent you getting electrocuted, the earth wire will carry that away. Okay, and then they've thrown some horrendous information at us here. It looks nasty. You've possibly never seen it before, but if we dig into it, then it's actually not too bad at all. It says, the question has nothing to do with it necessarily. State the difference between alternating current, AC, and direct current, DC. So what are we going to say? Direct flows only one way. So that's current that comes from something like a battery or a solar panel. AC, the current changes direction repeatedly. And interestingly, that's about 50 times a second. It's 50 hertz, so it's forward and backwards 50 times a second in the UK. Then it says here that we've got some information here. So the mains electrical supply in the UK is 230 volts. Use an equation from page 2 and information on the kettle to work out the resistance of the kettle. This particular question here, we're going to have to do two things. We're going to have to do a little bit more than we would normally have to do. I've started out by writing the wrong thing down and crossing that out, which I think is always a good way of doing an exam question. So we're going to do P equals I times V. So that's from the equation sheet on page 2. Because once I know the current, I can then do V equals IR to find the resistance in a moment. So a little bit of rearrangement so that I is on its own. So that's going to be I equals P divided by V. So that's going to be 2760 divided by 230 volts. And if we work that out on our calculators, then we're going to get that this is equal to 12 amps. Now, don't be tempted to write that down there because we've not quite finished yet. So I'm now going to do V equals IR and rearrange that. So I've got R equals V over I. So that's going to be 230 divided by this 12 from here. And that's going to equal 19.16 recurring. Now, you can write that down if you want, 19.16, or you can round it to 19.2 ohms. Okay, tricky this particular last one, but that's how I'd go about solving it. Hope you found it useful.